Hey guys, welcome back to Algebra 2. Mrs. Colette here. Today we're going to talk about 13.3 radian measure. So let's get started with our objective. It's to use radian measures for angles, and to find the length of an arc of a circle. So a central angle is an angle with a vertex at the center. That makes sense, right? It's the central angle. And an intercepted arc is a portion.
No.
What? What?
No. I know. Identity theft is a crime. So let me just. I got
Okay,
this.
all right.
You stick with the science, and I'll stick with the math.
Okay, that's the math
you.
here.
Bye. Okay, welcome back. We really are going to be 13.3 radian measures.
Yes, we are. All right, so I'm going to define some terms, and then Ms. Collette will give us some examples. So a central angle, remember, a vertex of an angle is where the 2 points meet. All right, so right there, that is our central angle, the intercepted arc. All right, so like in football, if someone throws it and you catch it before it gets to that person, all right, it's an interception. All right, so this arc, I'm going to go with a different color, blue. All right, and an intercepted arc, it's in between the two rays of that angle. Then a radian measure is the measure of a central angle that intercepts an arc. And so this same angle can be defined by angle or radian. So let's look more specifically at what that is. So some key concepts for us. This kind of just explains the why of what we're about to see is the what. All right, so when we want to convert from degrees to angles, we're going to do this, all right? So if we want to convert from degrees to radians, we're going to multiply by pi radians over 180. And we want to go from radians to degrees. We're going to multiply by 180 over pi radians. All right, now that may not make sense to you right now, but just know that for one of these, the pi and the radians is going to be on top of the fraction. The other one is going to be on the bottom. Ms. Colette is going to explain when to do the pi on top and the pi on bottom.
Perfect. So again, we are converting. The central angles can be represented by radians or degrees. And so we're going to go back and forth between that. And so these right here, this is what you need to write down. This is what you are going to switch back and forth between. Okay, and so the trick is to know when to use which one. So it's either going to be 180 over pi or pi over 180. So if we have the first one, says what is the degree measure of an angle of negative 3 pi over 4 radians. Okay, so we're given radians and we're going to go to degrees. And so what I always think about, so we have our, negative 3 pi over 4 radians. To know which one I want to do, we need to get rid of our pi. Radians is always in terms of pi, and degrees is just a number. Okay, so to get rid of that pi, we need to cancel it out. So we are going to be using 180 over pi. So with our 180 over pi, your pi's cancel, they cross cancel. So then all you have to do in your calculator is you can either, what they did is they simply cross simplify, which is fine. All you need to do is put in your calculator negative 3 over 4 times 180. Okay, and then you're going to get negative 135 degrees. Okay, so radians to pi, or radians to degrees, we have this pi in radians. Degrees is your number with your degrees, okay? And so now let's do one where we're given degrees and we want to go to radians. Okay, so whenever you have your radians, your central angle, it's in terms of pi. We need pi in our answer. So this one will be pi over 180. So we have 27 degrees times pi over 180 degrees because we need that pi in our answer. So all we need to multiply is 27 times pi over 180. Basically in your calculator, you need to just do 27 divided by 180. Okay, and that is going to simplify to be 3 over 20. So 27 over 180 is 3 over 20, and you have your pi, so 3 pi over 20 radians. And so angle of 27 degrees measures 3 pi over 20.
Thank you, Ms. Colette. All right, so some other complex things that we can do with intercepted angles and arcs and radians. Is let's say we wanted to find, so right here it says use the circle to the right, what's the length of S to the nearest 10th? So S is our intercepted arc, and we have to figure out what that length is. Well, the way we could do that is using this formula, where S, the intercepted arc, equals radius times theta, and theta is just the angle that's given. So, all you have to do is substitute. So we have our formula, and we're just going to plug things in. So, the 3 is our radius. They get that from right here. Radius of 3. Our theta is 5 pi over 6, and this is written in radians. Right there. So I'm just going to multiply these two together, and I can use my calculator for this. And that gives me 5 pi over 2. And if I wanted a decimal answer, it's 7.9. So once you plug this in, it will actually probably skip this step and just give you 7.9, or approximately 7.9. All right, that is it for the lesson. On the homework, what do we have?
We have 9 total questions.
All right, so good luck.
And if I'm not mistaken, not only is this done for this lesson,
Oh, wow. Yeah, you're right.
but it's done for
For the
we're done.
semester. For the semester, you're done with Algebra 2,
And we're done.
Semester 1.
Colette out.
Oh, wow. Dropping pins. All right.
Bye.
Adios.